Thank you for your patience. Now, this morning we launched our new product called AiSPIRE, essentially an AI-based knowledge-centric tool for GRC. Now, I have a couple of slides here, right? So I'm weighing my options. Do I repeat some of those slides in the morning so I can reset the context, or go straight to the product demo? But I guess you'll have to earn that right to look at the product, I believe. So let me ask you the question. So we said this morning, AiSPIRE helps address two questions. What are those two questions? There you go. All right. So we go straight then to the demo. All right. So on public demand. All right. All right. So really quick. So we set the context of one of the large enterprises that we worked with a pilot version of this particular product. Right. Now, this context is that of a large global bank with a very mature GRC practice, having about 500 GRC professionals performing risk assessments and control tests annually, right? Close to about 10,000 such assessments on an annual basis. Now, what we saw was for this particular bank, a large percentage of these controls that were tested were consistently getting passed, right? About 95% of pass rate among these controls. Now, this goes back to what Jonathan was saying earlier, right? So compliance doesn't always mean you're risk-free, right? Something like that. Now, when we looked at some of the other facts on the ground, we saw that this particular company was still being subject to regulatory fines. There are still lawsuits against this company and pockets of customer complaints. So the question then was, what was being tested across those 10,000 odd control tests, which seem to be passing with flying colors? Now, the CRO of the company asked these very specific questions. The first question was obviously, hey, what are we testing? And are these controls that we are testing, how effective these are in terms of identifying the risks and the coverage gaps? So there were questions specifically around if these controls were duplicate, if these controls were orphan controls, and did they have any meaning, whether they passed or failed. And the other set of questions were around patterns of over-testing and under-testing, right? So where we are spending a lot of time testing some controls which we knew were working very well, thereby taking a lot of time, versus where there are pockets where either the controls were weak or there were no controls, there was no coverage, and we didn't even test those. And the other element is the when, right? So when do we actually test these controls? Now, these questions, like I said in the morning as well, is very consistent with so many other customers that we speak to, right? So these questions resonate with most of our clients, and we see that there is a lot of value in addressing these questions using technology. Now, when we look at the current state of GRC technology, most of the technology today is workflow-based, process-based, right? Process flow-based. Now, they help answer that question of how to do something. That is, how do you conduct risk assessments, or how do you create policies, get them attested, so on and so forth. But the other element, right, of what needs to get tested, when these things have to get tested, aren't covered by technology. Most of it is, spaghetti processes, manually handled. Now, this is where we are launching AiSPIRE today to address these very specific questions. AiSPIRE is looking at all the functions of GRC across enterprise operational risk, regulatory compliance, internal audit, HR, cyber. It looks at the process risk control libraries, looks at the assessments, the historic assessments that have been done, and also looks at issues or signals that are currently active to then provide answers to these two specific questions, right? So what are the controls that have to be tested, and if there are control gaps, if there are coverage gaps that need to get filled up, and when is the right time to test these controls? With that, another thing about the product obviously is the way we've architected this is that this sits on top of any GRC tool. Now, it doesn't matter what GRC tool an enterprise uses, MetricStream preferably, obviously. However, some of these other problems, right, of control redundancies or the questions around what to get tested, etc., they're still relevant regardless. So the way we've designed this product is that it sits on top of any GRC tool and helps provide answers to these specific questions. Now, with this, we can go to the product preview. What you see here on the screen is, all right, is the a dashboard, the landing page of this particular product. Now this product, like I said, sits on top of the GRC tool. It connects to your existing GRC environment, looks at your risk controls data, your assessment data, your issues data, internal, external losses, customer complaints, frontline observations, what have you, and performs its diagnostics. It automatically runs these diagnostics in the back end and manifests these results in form of three things here. One is the analytics, plain simple analytics, insights, which are AI based insights, and recommendations, which is really the so what of everything that we're doing. Now, one of the things that we've learned over this time, right, working with all our customers, is the need for an intuitive UI, especially for a solution like this, right, which looks at a lot of data and provides these insights. There should be an intuitive way for end users to interact with this. And this further got reinforced by the viral adoption of ChatGPT too, right? With everything is now a question answer. So we've introduced this capability where end users can actually ask questions of the data and get responses in form of analytics reports or insights. Now here are a couple of examples I'll run through, right? So essentially, if going back to the example of this client where we saw 95% of these controls were consistently passing, now the other obvious question is, what about this 5%, right? So what is the trend of these 5% of controls year on year? Let's say I want to ask this question, right? So show all the failed control counts by the year. So you can type in this question in natural language and you get a result shown in here. Now in addition to this, we also auto generate insights based on the data to look at, for the end users, to look at, hey, what is standing out in this data set here, right, in the data that is retrieved. Now, one of the things when I look at this data, right, is there are all these controls that are failing, and we have data from 2018 to 2021 where the failure rate is pretty much consistent, right, between 5 to 7%. Now, a question that I have when I look at this is, are there repeat offenders, right? Are there some controls that consistently fail year on year? So that is where you could go ask a question to retrieve an answer. So you can say, show all the failed controls and its counts. So this is now going to look at the data, come back with all the controls that have failed over the period of the data that we have. Again, this is straightforward analytics at the end of the day, right? The natural language question, yes, there's a cognitive element to it, but so far it's straightforward analytics. Now we can look at this and see that this control that ends with 1066 is a control that seemed to have failed 14 times in the 4 years of data that we have. Now when a risk manager or an analyst looks at this, the question then is, say, what is it about this control that it is failing? And is it just restricted to this control, or is there some other pervasive issue? Now this is where, using our technology, we are able to join different aspects, siloed aspects of the enterprise and identify if there are pervasive systemic issues. Now, one of the major advancements that we have made is essentially to incorporate a graph database, right? So far, like Joy talked this morning, the evolution of technology, especially on the data side, was from relational databases. Now we are migrating from relational databases to a graph-based approach. Now in the graph database, obviously there are some benefits which I'll touch upon here. But what you can do with this, right, especially for a GRC domain, we see there are a lot of interconnections that are possible across all these library objects. Now some of these interconnections are set in by the end user, and some of these are left unconnected. That is where a system like a graph database is able to identify those missing links and start linking them together. Now in this case, I pulled up this particular control that had failed 14 times. I have pulled this up in my graph database, in the graph explorer, if you will. Now I see that this control, over a period of the time that it's been tested, has failed 82% of times. That means, you know, it's a very high failure rate. Now this control has to do with AML based training for the employees. Now when I look at this, right, the courtesy of the graph database, we are able to see what are all the other elements that this particular control is connected to. A lot of it is straightforward, but then you see this here, right, a theme. Now theme is something that our AI model generates. Basically it's looking at the entire data set trying to figure out those areas where there is thematics of, let's say, control redundancies. So we create that theme, and we then start linking all those controls that belong to these themes together. Now here we see that this particular control belongs to this theme. Now you can go and explore what this theme looks like, and you see that the theme got pulled up. Now when you look at the details of the theme, you see that this particular theme is actually connected to 6 controls. So what this is telling us through machine learning is we started off with one control that had failed 82% of times, but then this was not a standalone control. Looks like there's a lot of duplication. There are in fact 6 other controls across the enterprise that have the same theme. Now we can look at what these 6 controls are in totality and see how they are performing. Now I pulled that up here. So essentially these are all those 6 controls that are in the blue ellipses, and you see the reds, these are all the risks that these controls are connected to. Now in the sans AiSPIRE, all of these would have been siloed. Now because of the machine learning intelligence and the graph intelligence that we bring in, we are able to join these siloed elements of these controls together and see that there is a connected pattern. Now when you in fact look at these controls, right, you look at this control here, this control has failed 59% of times. Now this other control has failed, well, this is what we started with, 82% times. Now this other control has failed 65% of times. Now all of these controls have been defined for different lines of businesses within the enterprise. They all have to do with training around anti-money laundering, and all of these have consistently failed regardless of which line of business these were tested under. And it so happens when we actually looked at the data, by the way, a lot of this data is also masked to obviously remove some company confidential and identifiable information, but these are patterns that we are seeing. In fact, just an anecdote, right? So when we actually presented these results back to the customer, there was a team of about 20 people, right? So of course, these are all risk analysts. This is what they do day in and day out. And it triggered a 5-minute discussion amongst themselves on why they actually missed a pattern like this. Now it's obvious, right? Because everybody is busy testing their controls, they are focused on their specific silos, and they miss the fact that there is some underlying problem that exists. Now this is one element, right, of what you can do with a system like ours. Now as we work with a lot of our customers, it's very evident, especially large enterprises have a lot of lines of businesses and a lot of controls, and these controls grow over time. And if left unchecked, obviously results in a lot of duplication and similarity in those controls that are created, and also inconsistencies, right, across how these controls are getting tested across their different orgs. So to address this very specific problem, we have created what we call as a control canvas, essentially a place where our risk managers can come in and look at the level of duplication that occurs in their control environment. Now in this case, for this enterprise, we see that about 72% of the controls are unique, right? It's very well defined and they're doing what they're supposed to do. But then we see 28% of the controls are duplicate or they are similar, right? So there is a lot of overlap in what those controls are supposed to be doing. Now we further break this down. Obviously for large enterprises that becomes very important in terms of where is the duplication? Is the duplication happening within the same line of business, or is it happening across lines of businesses? And we also slice and dice this information and group these controls thematically. Now for this case, we see that anti-money laundering and terrorist financing, so these are two themes where there is a lot of duplication. And this kind of makes sense because a lot of lines of businesses here had to do with retail banking or consumer banking or wholesale credit, right, and corporate banking. And there's an element of AML that cuts across all of these lines of businesses. And it was no surprise that the controls were duplicated, and those controls that had failed in one, those similar controls had failed in the other LOB as well. Now you can obviously get into some details of what this looks like. Now we see that in the slicing and dicing of this 28%, and when you add this filter of AML, you see what these controls are. You see about 2% of the controls are similar within the same line of business. You can go in here and see what those controls are. As you can see in this example, you have a control that ends with 128. It's defined as something to do with data analysis tools for suspicious transaction monitoring. Is very similar to another control that also talks about data analysis reports. And when you look at the descriptions and when you actually start reconciling the testing procedures that are in place, a lot of overlap. Now we also look at what this overlap is and also what the impact of this overlap has been on the time the organization spends. Now here is where you see that these controls together, now over the course of that 4 years of data, have been tested 42 times. And we know typically, right, even a very aggressive estimate of testing a control is about 20 hours. So you can imagine, right, between 20 to 40 hours is what it takes to test these controls. Now these have been tested 42 times, very similar in terms of what they are supposed to do, very similar sampling, but these have been tested by 2 different individuals at different times of the year and being tested 4 times each. Now the question then becomes, what can you do with this, right? So that is that's where we start driving recommendations. First, we surface these problem areas and recommend to the end users on the potential of they rationalizing these controls, merging these together, or maybe throttling down the testing frequency. Now in this case, maybe it's okay because these controls over the 42 times these have been tested have consistently passed. It looks like there's no systemic issues around these. So maybe you could, instead of testing both these controls 8 times every year, let's throttle it down to maybe 4 times every year, right? So there's savings. So as you start adding this up in terms of how much of efficiency we can drive over a period of time, right, across different controls, you see the numbers start adding up. Now this is one element, right? So one element of the optimization that we do. But then the other important element is also looking at the signals. Now for us, signals essentially are issues, are frontline observations, could be risk events, internal and external losses. Now these also should inform the testing schedule. Now a lot of times we see that the testing schedules are preset, and based on some preset schedule, the GRC tools of today, they generate an alert or a task for testing and somebody goes in and starts testing. But then if we hook in this testing schedule to a more intelligent queue that looks at all these signals of what is happening and is it really relevant and timely to go test that particular control, we see that we are also able to drive efficiencies, right? So one is to identify those controls that we may not have tested for several months because it was not in the testing schedule for now, or the contrary, right? There may be some controls where there are no signals and everything looks fine. Why spend that additional time testing it right now? Now we do provide recommendations on the signals as well, recommendations on what could be those controls that are either weak, which is maybe a cause of this particular signal that's coming in, or that could be impacted by the signal that's coming in. We also identify areas where there are no controls at all. There is the control gaps. So it is a cue for the business users to figure out that there is probably a gap and this gap needs to get filled out by defining a new control. And we also slice and dice this information based on the themes, right? The themes around the signals. Now, everything that I've described so far, right? So I went through some key elements of what this product does, but then it eventually culminates in the recommendations, right? The so what of whatever we are doing. Now we provide out of the box what we call as an optimization strategy, and there are 3 strategies that we provide out of the box: a conservative, moderate, and an aggressive optimization strategy. Now each of these strategies help you do 2 things, right? So optimize the duplicate similar controls, that is the control rationalization. How many controls can you maybe merge or eliminate because there is a redundancy. And the other element of rationalization is the control test frequency. So how many control tests on an annual basis can you reduce? Now in the moderate approach, we see that if I just look at this particular data set, now in this case, like I said earlier, 28% of the controls were duplicate or similar. We are coming back and we had about 2,000 controls in this particular customer's test set. We came back and we said with a moderate approach, they could probably optimize about 200 controls. And also optimize the control test. Now here, as you can see, the control test from 2018 to 2021 had been consistently growing. At 2021, they had about 4,000 control tests that was conducted in that year. They were taking all of the data that I just went through, right? The signals, the redundancies, the similarity among controls, similarity around the lines of businesses, and we are coming out with a recommendation and saying, hey, based on everything we are seeing, for your configuration of a moderate optimization strategy, you could actually drop the number of control tests from 4,000 to 3,200. It's a 25% reduction. Now you could just as easily, select the aggressive strategy and see what the savings are. And in the aggressive strategy, we are saying you could actually reduce the control tests by about 40%. Now in all this, right, in this data set, the way we worked this was we looked at 4 years of data and we tested or we validated our outcomes, the model outcomes, against 2022's outcome. And we actually compared what was done actual and what the model recommended, and we saw that we could drop 40%, although it's aggressive strategy, we dropped 40% of the control test. It was dropped without dropping even a single test that had actually failed in 2022. Right? So this efficiency gain right there. Now, this is what the control test plan looks like. Essentially, we produce a plan. The plan tells you what the line of business is, what the control is, and what our recommendation is. Now you can, let's say, aggregate this data. Let's see. So there you go. So now in this plan, we've said, you know what? So there are 30 controls that we think we have to go retest because we found some signal, and based on the signals that we are seeing, it's better that you go retest these controls. Don't wait for whenever it is scheduled next. And there are about 240 controls across all the lines of businesses that we think you can optimize. Again, optimize, we are also very conservative, right? Even though we call it an aggressive strategy, the thresholds and the factors we have set are pretty conservative. We don't completely eliminate testing. The max we drop is by 50%. So in this case, for the setting that we've said, for a lot of these controls, these were getting tested at least 4 times in a year, right? 4 times, in many cases there were 12 times in a year or 16 times in a year. Now all of these, we said, you know what, drop it by 50% and drop it by 50% without affecting your risk coverage and still gaining efficiency. Now we also provide end users with the capability of configuring these factors that go into the optimization strategy. As you can see here, 3 specific areas. One set of factors have to do with control performance. That is, how have these controls performed historically, and what the risk rating of the risks that are tied to this control are. What are any impacts to the associated libraries, right? So it could be a particular control may be tied to a process, and let's say the process owner change. So that's an impact. The organizations can choose, do they still want to optimize the testing frequency if such a change has occurred, or do they not even want to consider optimizing if such changes have occurred? And if a change has occurred, how long do you wait for you to rebuild a history on that change before you're ready to further optimize? So we have 3 set of factors that we provide out of the box in the product today. One is around control performance, one is around signal management. That is, what are the kind of signals that you look at to inform your control test plan. And the last piece is around network intelligence. Again, this we see, right, especially for large enterprises where there are a lot of lines of businesses, there is a lot of similarity, like Jonathan was alluding to earlier, right? So the ability to learn from across different groups or different line of businesses. So we use that as well. We built a concept of a risk profile, which is basically a fingerprint for every line of business, and this fingerprint is used to figure out what are those lines of businesses that are very similar to each other and can learn from each other. So again, well, I'm right on time. Could go on and on. However, I'll pause here. I believe it's a break right now. So we'll be available for any specific questions you all have. All right. Thank you.